We already learned about the frequent pattern mining and association rules. So we learn how to get the frequent item set and then how we can get the association rules. So we need to understand which patterns are interesting, because when we look at those patterns, there might be some questions whether those patterns are interesting or not. Yes. So we will learn about the pattern evaluation methods. So let's see this table. In this table, we have basketball, not basketball, cereal, not cereal. So maybe I can say that this is the number. We have 2000. It means from our data, we have 2000 who like basketball or who play basketball, and he also eat cereal. If we have not basketball, so we have data where the person who do not play basketball and he eats cereal. Maybe the data will be something like this one. This one is play basketball, cereal. And the other data is he is playing basketball, but he does not eat cereal. He play basketball and eat cereal. And then didn't play basketball and eat cereal, and so on. So we have the data and then we calculate the numbers. So this is 1, 2, okay. So this is the person who play basketball and eat cereal, play basketball and eat cereal. So we calculated there are 2000 people who play basketball and eat cereal. And we have the total data. So summation, the total data is 5000. We can have also the summation. The person who play basketball, we have 3000, and the person who eats cereal, we have 3750. Okay. So this is the summation of the row, and this is the summation of the column. Okay. Now I would like to know if we have this rule: play basketball and eat cereal. I want to check whether there is an association between this data. As you might know, we learned that this one, okay, this array, we have the first is the support and the other is confidence. So what is the support? The support is 40%. How can we get this support? We know that the support should be divided with the number of the transaction. Okay. So the number of transaction means the total data. Here we have the total data is 5000. Now, what about the play basketball and eat cereal? So play basketball and eat cereal, there are 2000. And the total data is 5000. And we can get this 40% is from 2000 divided by 5000. Then it is 0.4 or 40%. What about this confidence? this confidence, we want to get the total number of play basketball and cereal. If we look at the formula, it is, let's say this is x and this is y. So we will divide with the total number of x. Okay, so play basketball and cereal, we have 2000. And we would like to divide with the total number of play basketball. What is the play basketball? The total number is 3000. So we will divide with 3000. Then we get this confidence, or 66.7%. We call this result is a bit misleading. Why it is a bit misleading? The overall percent of students eating cereal, the person who eating cereal is actually 75%. So it is higher than 66%. So it's a little bit strange. We have confidence 66.7, but actually the number of students who are eating cereal is 75%. Okay. And we can look at the other kind of categories: play basketball and not eat cereal. Play basketball and not eat cereal. So the spot is 20%. How can we get this 20%? We have the 1000 divided by the number of data. So we have 1000 divided by 5000. Okay. And the confidence, how we can get confidence? Again, we will check the number of this play basketball and not cereal, which is 1000 divided by the number of play basketball, which is 3000. Okay, then we will get 33.3%. So here we can say this is a bit more accurate, because in the person of not eating cereal, is still in the 25%. Okay, is still lower. Okay. But we have very low support and low confidence. It's only 20%, only 33%. We cannot see any correlation with the support and confidence. So we can use leaf. The leaf is, actually this is the probability of A intersection B. So it's not the union, sorry. A intersection B divided by the probability of A multiplied by the probability of B. So let's see the example. I want to check the leaf of B and not C. What is the meaning? B here means basketball. Not C means not cereal. Okay. What is the leaf of basketball and not cereal? So first we will check the intersection. What is the intersection? Basketball and not cereal. We have 1000. And we will divide with the total data, which is 5000. So 1000 divided by 5000. We got this one. And we will divide with the probability of A multiplied by probability of B. What is probability of A? This is the probability of the basketball. The probability of basketball is 3000 divided by 5000 multiplied by the probability of not serial. The probability of not serial is 1250 divided by 5000. So we get the value is 1.33. Now let's see if we have another possible leaf, B and C. So B means basketball and C means cereal. So the intersection between B and C, it is 2000 divided by the total data is 5000. Okay, divided by 5000, and we will divide it with the probability of A. What is A? This is the B. Okay, we want to get the probability of the basketball, which is 3000 divided by 5000 multiplied by cereal. The cereal is 3750 divided by 5000. Okay, so you will get the number of leaf, this one. Based on the measures, okay, there's the conclusion here. If leaf is higher than 1, then it shows a strong positive correlation. And it means that it is a meaningful association. Okay. If you look at this one, it is less than 1. So it is less meaningful, or the association rule is not that meaningful. This one is more meaningful. So I can say that there is a correlation between the basketball and not eating cereal. Actually, there are many more interesting measures. So let's say this one, this is an example by walnuts, and I want to check whether there is an association with buy milk. Do you know walnuts? So maybe not many people like walnuts. Only some people or very less people like walnut. But I want to check based on the transaction in the supermarket. Okay, the person who buy walnuts and buy milk, there is 1%. So it's very low. And the confidence, however, is very high, is 80%. If you still remember, the confidence, it is from the total number of this product, or this the X. Okay. So we divide with X. If we divide with X, it means I have a confidence, I have a high confidence that if someone buy milk, if someone buy walnuts, he will buy milk as much as 80%. But it might be misleading if 85% of customers buy milk. So if there are many people who buy milk, but maybe only very small people who buy walnuts, so it can be misleading. So sport and confidence are not good to indicate correlations. Instead, we can use leaf or chi-square. So if you still remember the chi-square, the measures that we learned in the first part of our lecture. Okay. So it is a good measure for finding the correlation between two categorical attitudes. And actually there are 20 interestingness measures. So you can look at this one. I cannot explain one by one because it depends on the data set, it depends on the purpose. So which are the good ones? Yeah, it depends on what kind of data you want to analyze. So at least you know we learned the 3 basic measures: support, confidence, belief, okay? And we also learned about the chi-square. So those 4 are good enough for the interestingness measures in association rules. Okay, now let's check in the audience. We can use the function association rule and frequent patterns in the audience. First, you need to install associate function. So you need to select option and then you can select add-on. You can select option. The option is in the top menu. Okay. And then you can select option and then select add-ons. And there will be a pop-up. So in this pop-up, they have many add-ons. It means you can include some additional functions that are not existing in this widget. If you look at this one, the orange, now it has a new version. So you have associate. So associate means it is an add-on for enumerating frequent item set and association rule mining. And there's an action install. So please install it in your computer. Okay, it takes some time. It depends on your computer. Yeah, if your computer has a good spec, I guess the installation will be faster. Okay. And after you install the tools, you need to restart. Okay, so in my case, I will restart my Orange. And once you finish with the installation and once you restart the tools, you will see there's a new widget here. They call it associate. So if you open this one, you will see the frequent item set and association tool. Now let's go to the example. Let me go to the first example. Association 01, I share already in the e-class. You can download it. First, I need to read the data using the widget file. The association example 01. So you can look at this data. It has 6 columns and we have 5 instances. If you open the data table, so the data will be something like this one. If you still remember in the PowerPoint, in the first part of our lecture, we have this bread, milk, bread, diaper, beer, eggs, meat, diaper, beer, coke, beer, bread, milk, diaper, beer, bread, milk, diaper, coke. Okay. And when you represent it in the data table for the association rules, you need to make something like this one. So you have the true, false, and each of the item will be in the column. Okay. If you check on this, bread equals to true and milk equals to true. How about diaper, eggs, and cook and beer? All of them are false. So I can see that, okay, the transaction 1 or customer 1 bought bread and milk. And so on for the transaction number 2, transaction number 3, and until transaction number 5. And using this data, we can try to find the, just use your file, we can find the frequent item sets. The frequent item set here, we can check what are the frequent items based on the minimum support. So last week we learned how to create the minimum support. If we have a minimum support value, so we can calculate what is the items which satisfy the minimum support. So let's suppose I make the minimum support is 50%. So you can find the item set. You can click, and all the item set which has more than 50%, it will appear in the result. Okay, so bread true equals to 4, milk true equals to 3, x false equals to 3. Okay, so it also includes the false. You can make association rule. And you can determine the support and the confidence. So as we already learned last time, we need to determine first the support and the confidence to find the frequent item set and to find the association rule. Let me make 50% and 50% for both support and confidence. Let me do this one. I can find the rules, and you will see the possible association rules based on the minimum support 50% and the minimum confidence 50%. And you can find the support, now it has like 0.8 and the confidence is 1. So you can sort confidence. Let's say I want to check from the highest confidence. So I check this one is 1. And if you still remember when we learned the association rules, we have the X association with Y. We call the X is the antecedent and we call Y is the consequent. Okay. The antecedent, it means the X. We want to see the association with Y or the consequent. Now, let's suppose I want to check if all the condition is true. Okay, so you can put here, it is filtered by the antecedent, you can filter by the consequent, and what are the keywords that you want to write here. Let me just use true, and then you can find the rules. So everything that contains true, it will appear in the result. Sometimes it is, yeah, you can see there are many results like this one. So it is difficult to analyze this data. We can just select maybe top 5 or top 10 from this list. Let's say I want to select only top 5 because it shows the high confidence. The confidence is 1. So I can recommend to the owner of the supermarket if you want to make a good promotion, you can see from this result that the frequent patterns, or there is an association between milk and eggs. Okay. Oh, you can see if the person did not buy eggs, he will buy milk. So it is like the opposite one. Okay. So in this case, you can also filter. If you do not want to put this one, you can filter only the true. So you can put the true and true, then yeah, the list of the association rule will be less than before. So it will be easier for you. Okay, I can check this one. This will be the highest one. Beer and diaper, there is a high correlation because it shows the high support and high confidence, and also it shows the higher leaf. As you know, leaf, if it is higher than 1, it shows the strong positive correlation. In orange, they show another measures like calf rates, strength, life rates, but let me skip this one. Okay, so you can just use the support, confidence, and leaf as your analysis. The second data set that I want to share to you is the golf play. I give you a data set called play. What is golf play? Here is the data about someone who play golf. And this is the person number 1. He or she did not play golf. When the weather is rainy, when the temperature is hot, when the humidity is high, and when there is no wind, or windy equals to false. And based on this one, we know that, okay, then in this condition, the person did not play golf. The other data shows rainy, hot, high, and windy is true, but the person still did not play golf. So I can check the person who play golf, okay, and I can find the patterns. What are the patterns that the person will play golf? If I know the patterns, someone who wants to play golf in certain kind of condition, then I can make promotion. So let me use this association rules. What is the frequent item? Let me check the item set. Okay, with the minimum support 50%, I can say that the data contains humidity high, humidity normal, windy false, and play golf, yes, which is more than or equal to 50%. And what about the association rules? Okay, let me delete this true. Now I have minimum support 50% and I have minimum confidence 50%. Let me find the rules. Oops, nothing. Why? Is it error? In this case, you need to lower the support and the confidence. Let me make the support is 30% and let me make the support confidence is 30%. Let me find it. Okay. Now it shows the result. It means when you cannot find the association rule, you need to adjust or you need to modify the support and the confidence. Okay. Now you can look at this result. Someone who play golf, it is when the humidity equals to normal. And someone who play golf when the windy equals to false. Okay, then as the golf resort owner, yeah, you can make promotion when the windy equals to false, or when there is no wind, you can give more discount, so you can attract more people to play golf. So this idea will help the business decision maker. Now, the other examples that I want to show you is there's one data set given from the WeChat data sets. So you can go to this data. If there is a data set here, I will use this data set. And in this data set, there are many data sets available for you to use to analyze in the data mining class. So I want to use this footmap 2000. You can double click on this one. And once you click this, you can use this data set. So you can see this is a green color. Okay. So when it is showing the green, you can use it for your analysis. Let me just use the data table. So this is the data. We have 62,000 instances. And what is it? It shows that this is the transaction ID 1. The transaction ID 1 means the person or the customer number 1, he visited store ID number 2, because store ID number 2 equals to 1. So it means that this food mart has many branches. They have many stores. Store ID number 1, store ID number 2, store ID number 3. Okay. So let's select the Hanaromat. There's one Hanaromat in Mohyun, Hanaromat in Oppo, Hanaromat in Gwangju. Okay. So there are many stores, and this transaction happens in the store ID number 2. And the transaction 1 contains soup equals to 2. It means there are 2 items of soup has been bought, and there are 3 items of pasta has been bought by this person. So the data is more complicated because it contains the number of items. When you go to supermarket, you can buy 2 boxes of milks, or you can buy 3 baskets of apples. So not only one. Our data set, the previous data set, we assume we have only one. So this is more real data. Now you can also do with the frequent item set, and you can also do with the association group. In the frequent item set, let me use minimum support 50%. If you click, nothing, because you need to lower. Let me change to 10%. Okay, now I can see the highest item sets are fresh vegetables. Okay, because this is the supermarket for food mart. So all the items are related to food. And the highest items is fresh vegetable. What about the association rules? Okay, let me just set this. Oh, nothing happened here. Why? In supermarket, there are many items. Maybe the support is too high, so you can lower it. Or make it until 5%, maybe. Okay, let me find the rules. Okay, now I get one root with the minimum support 5%. So it's very small. And the minimum confidence is 25%. You can make it lower. Okay, it's still not showing many results. Okay, you can see now there are two results. Okay. With this association rule, you can see that the person who bought fresh vegetables, they also buy the fresh fruit. Fresh vegetables, fresh fruit. And the confidence is very low. The support is also very low. And you can see that the leaf is higher than 1, but it is slightly more than 1. We can still say that there is a strong positive correlation because it is higher than 1. If you want to have more result, of course you can lower this confidence, maybe 5%, maybe 7%. You can lower than this one to 1%. Now you can get more results. Okay. So if you ask me, what is the best minimum support and what is the best minimum confidence? It depends on the data. Okay. In this data set, you have very low support and low confidence. For other data set, maybe you need to set a higher support and higher confidence. Okay. That's all for this chapter. So you learn about the basic concept of the association rules, and you learn about the methods a priori, and then we learn about the pattern evaluation methods. Any questions? If no question, then I will continue because we still have some time. I already give you one more materials about classification. So in this chapter, we will learn more about the classification, what is classification and prediction. And we will check what is supervised and unsupervised, what is classification and what is prediction, and what are the issues regarding classification and prediction, and classification by decision tree induction. So first, we need to learn about the basic concept. Okay. Supervised learning and unsupervised learning. So I give the definition in Korean. For the supervised learning, we call it 지도학습. When we have this figure, when we have this image, we can put label. We can say that it is a dog. When we have this image, okay, I know that it is a cat. So we put the label, or we put this kind of name of that image. Because it is supervision. The training data, which is the observation or the measurements or etc., are accompanied by labels indicating the class of the observation. I can say that, okay, this is the class of dog, and we can have another dog. We can have another dog. So the new data is classified based on the training set. We have another learning approach, we call it unsupervised learning. So it is 비지도학습. In our data set, we only have pictures, but we do not know what is the meaning by this picture? We don't have label, or the class label of the training data is unknown. Given a set of measurements, observation, and etc., with the aim of establishing the existence of classes or clusters in the data. So if I have this kind of figures, I can just do something like finding the similarities. Okay, maybe they have the same year. Okay, they have the same year, so I can put all of them into one category. Okay, maybe they have the same shape of the face. I can put those two into the same category. So we call later on the clustering. There's another way to do this learning approach. We call it the semi-supervised learning, okay, or Junjido Haksup. In this case, some data are labeled. Okay, I know that this is dog, okay, so we put the label. Okay, I know that this is cat, so I put the label. But there are some other figures, there are some other images which are unlabeled, because maybe I do not know, or yeah, it is not identifiable. So I can just put those are unlabeled, and we call it this is the semi-superficial, because the training data are accompanied by labels partially. So not all data has label, only some others are unlabeled. So the number of labeled and unlabeled data will affect the learning approaches. So there are many other kind of learning approach like zero-shot learning or one-shot learning and etc. It is a part of this semi-supervision. We can have another kind of learning approach. We call this is the self-supervised learning or 자기 지도 학습. This self-supervised learning is similar to this unsupervised learning. So if you still remember the unsupervised learning, this one, okay. So it is similar with this self-supervised learning. The similarity is, yeah, first we need to start with what we call as the pseudo label. Pseudo label. It means you will create the label based on the similar properties. So as I mentioned to you, okay, I can see this is the ear, okay. So they have the similar ear, so maybe they are in the same categories. So I can make this is the animal one. They have also the similar category, maybe because of the head or the weight. So I can put those two in the same category. They are in the animal 2. Then after I know this is animal 1, this is animal 2, it will follow with the supervised learning approach. Because I already have the label. I already have the label. Okay. So I give this definition in Korean for you who wants to understand the Korean. I got this from one Korean professor, Professor Sok. Okay? So you can have the definition more clear about supervised and unsupervised learning. Okay, I guess I will stop here. Okay. Any questions, comments?